Chapter 3, I think, is the friendliest chapter. So I'll just jump into this. The first problem wants us to make a frequency distribution, and a frequency distribution is just a table, a two-column table, and let me just go ahead and make this. And I'm going to make a table to look a lot like this because the data in problem 1 are scores on an OChem exam, and so I'm going to make a table, and in the left column I'm going to put a test score. In the right column, I'm going to put number of students, just because I believe these are test scores for the number of students. So I'm going to make a nice two-column table. And the big difference between this table and the table that I flashed up is the table that I flashed up, 50 to 59 was supposed to be the first row. Here it tells me that 20 to 35 is going to be the first row. And then I'm going to need to add a few rows, and I don't know exactly how many I'm going to need to add, but I need to get up to so that 97 will fit in one of in the last row, essentially. If I take the difference between 35 and 20, I get 15. For each of the categories I make, I'm going to add 15 to get the end number. To get the first number, I'm going to add one from the last list. 35 plus 1 is 36, and then 36 plus 15 is going to be 51. For my next category, I'm going to bump the 51 up to a 52, and then take 52 and add 15 and get 67. Still not enough because I need to get all the way up to 97. I'm going to go from 68, and then 68 plus 15 is 83. And I finally think I'm going to get to the last one. I'm going to go 84 and add 15 and get 99. That's going to be far enough in terms of the number of rows. Often when I make a frequency distribution, I make the bottom row as a total row. I'm going to go ahead and do that. So this is a reasonable start for the frequency distribution that I'm making here for this problem. Now for each category, I just need to write a number of students. First one for 20 through 35, I'm going to put 3 in that category because there's 3 students that had that test grouping, or those range of scores. And then for 36 to 51, I'm going to put those 2 students. 52 to 67, I'm going to put those 1, 2, 3, 4, 5 students. 68 to 83, 1, 2, 3, 4 students. And then 84 to 99, 1, 2, 3, 4, 5, 6 students. 4, 5, 6, 7, 8, 9. My table up here has 20 students. If these numbers don't add up to 20, I've made a mistake. So 3 plus 2 is 5, plus 5 is 10, 14, 20. So this is an adequate frequency distribution for the data that's provided. So that would be my answer to 1A. For 1B, the total number of observations is just the 20 scores. If I counted up all the individual scores, there's 20 scores. Part C is the tricky one. The width of each class is defined by subtracting the first numbers in any 2 consecutive columns, or any 2 consecutive rows, should I say. So I can take 36 minus 20, which would be 16, or I could take 84 minus 68, and that's going to be 16. The width of each class just involves subtracting the firsts in any 2 consecutive classes. Actually, you can subtract the lasts as well, but anyways, we're going to say it's 16. The midpoint of the third class for part D, 20 to 35 is considered the first class. 36 through 51 is the second class. The third class is 52 to 67. And to get the midpoint of the third class, I have to add the numbers that start and end that class and divide them by 2. So I need to do 52 plus 67 divided by 2. And on my calculator, to make sure it does it right, I'm going to put the 52 plus 67 in a parentheses and then follow up with a divide by 2. And I get 59.5 for my answer to part D. For part E, modal in some sense means most. So when it says find the modal class, it means find the class with the most observations. And for me, for this particular table, the last class, the 84 to 99, has the most number of students with occurring there. So I'm going to put that as my last class. And then if I was going to add a class, its beginning number is going to be 100 because 99 bumped up by 1 is going to be 100. And then I added 15 to get the last number for each one of these. So it's going to be 100 plus 15, which is 115 for the end. That's all there is for a frequency distribution in the questions for number 1. Question 2 wants me to create a frequency histogram, which I would call like a bar graph, and a frequency polygon, which I'll call a line graph, from the data that's provided in the table. So I'm going to start off doing my bar graph or my frequency histogram. I'm going to do it in blue, and I'm going to do my line graph in red, and I'm going to show them on the same graph. When I did these in the video, I got lazy and did them on one graph as opposed to doing 2 separate graphs, because it seems kind of silly to create 2 separate graphs when you can get all the information in one graph. So on the x-axis, for lack of a better word, I'm going to put the test scores. So let me label the x-axis here. And on the y-axis, I'm going to put the number of students. My y-axis needs to go as high as 15, and I think I can do it by incrementing by 1 on my y-axis. I don't need to put the total anywhere, so these numbers other than the total are going to show up on the y-axis. Let me try to get up to 15. You could certainly increment by 2 or 3 if you don't want to increment by 1 to get the numbers on the y-axis, because I might kind of run out of room, and I can live with that. You notice my little marks are getting closer and closer together. And then I'm going to be lazy and put a 15 on the top of my y-axis. So there's 9, 10, 11, 12, 13, 14, and then 15 didn't fit so well. So I have a pretty weak y-axis, but it's absolutely good enough for what we're doing. And now, above each of the classes here, I'm going to make a bar of the appropriate height. Above 50 to 59, I'm going to make a bar that's 1 high. And I kind of put that little tick mark in the center. You don't have to connect the bars, but I generally do. Between 60 and 69, I'm going to make a bar that's 3 high. Between 70 and 79, a bar that's 8 high, the best I can, 8 anyways. Between 80 and 89, the bar that's 15 high, that goes to the very top of mine. And between 90 and 99, a bar that's 9 high, so 9's about there, I guess. I'm not going to take a ruler and check your work that closely, as long as like 1 is the shortest bar, 3 is the second shortest, 15's the highest, 9's the second highest. If those were the numbers on your frequency histogram, just as long as they're kind of relatively okay. So that's the frequency histogram part of this. Now I'm going to make my polygon, and to do the frequency polygon on the same graph, generally right in the middle of the top of each bar, I'm going to put a dot, and I'm going to connect those. So my frequency polygon is going to be in red, my frequency histogram is going to be in blue. So this is a combination frequency histogram and frequency polygon for this data. Now I'm just going to connect these points. That seems absolutely adequate for this problem. You don't have to do any more than that. It's just organizing the data in a bar graph and organizing the data with a line graph. 3 wants me to create a circle graph. And generally, we show the percent in the circle. So what I'm going to do for this data, so apparently a group of people were asked their favorite color. Here's a frequency distribution without the total column. I'm going to need to add up these numbers and make each of the numbers into a percent when I go to make my circle graph. So eventually I'm going to make a circle graph. If I add up the numbers 50 plus 100 plus 25 plus 25, I get 200. For each of the numbers associated with red, blue, purple, and other, I'm going to find a percent for them. The first number I'm going to find a percent for is how many people said of the 200 said that red was their favorite color. As a decimal, if I divide 50 divided by 200, I get 0.25. 25% of the people said that red's their favorite color. For blue, 100 over 200, which is 0.5, or 50% said blue is their favorite color. And the last two, 25 divided by 200, 12.5% said those purple and other were their favorite color. Now I'm going to make marks on my circle to represent these percents and put the name of the category along with the percent in it. The easiest one for me to do is 50%, because 50% is exactly half the circle. So I'm going to draw a line that cuts the circle in half. It doesn't have to be this direction. You could draw a line any direction. But in the half of the circle that you create, you should put the color name and the percent of people that pick that color. I made easy percents here to draw, and if I do this on the test, I'm also going to make easy percents, ones I don't have to estimate so much. The next percent that's probably easiest for me to draw is 25%, because a 25% is half of a 50%. This area down here is 50%. If I cut it in half, I get a 25%. And both of these halves are 25%. I'm going to call the left half red, but you easily call your right half red. And under it, I'm going to put 25%. And the nice thing about the way I made these amounts, this shape here is 25%. Half of 25 is 12.5. I'm going to cut this 25% quantity in two, and to get two 12.5% quantities. So one of them, I'm going to write purple and say 12.5%. And the other one I'm going to say other, and I'm going to write 12.5%. I show in the videos, some sections that aren't perfect, like maybe some 10% regions. I can't imagine on the test me making the regions very complicated. I think 50s, 25s, and 12.5s are nice sizes to put on a test, and that's kind of what you probably should expect. All right. Problem 4 gives me a circle graph with percents in it, like we've just created for the Milton family, and it says the Milton family has monthly income of $2,500, and this chart shows how they spend their money. Question A says, how much money do they spend on rent? Well, they spent 25% of their salary, of their income on rent. I'm going to take 25% and make it into a decimal. I'm going to multiply it by the $2,500 that they make each month, and that will tell me how much. They spend 25% of $2,500, or $625 on rent. The answer to part A is going to be $625, because that's 25% of $2,500. Part B wants to know how much more do they spend each month on food than rent. Well, I know on rent they spend $625. They spend 33% of their budget on food. Let me figure out how much they spend on food by taking 33% as a decimal, which is 0.33, times the $2,500. So on food, they spend $825. To answer the question, how much more do they spend on food than rent? Well, the difference between $825 and $625 is how much more they're spending on food. And the answer to part B is going to be $200. I could say $200 more or $200 more is spent on food than rent. As long as you give me the $200, I'll be fine. 5 gives me a frequency histogram where the bars aren't connected. And it's kind of the same kind of frequency histogram we've been dealing with. We have students' grades and the number of students that had that grade. And let me, on top of each of these rows or columns, put numbers. 5 students scored between 50 and 59. 10 students scored between 60 and 69. 15 students scored between 70 and 79. 20 between 80 and 89, and 15 between 90 and 99. How many students scored less than 50? Well, the students I'm going to count up less than 80. Those students that scored between 50 and 59 scored less than 80. I need to count them. These students that scored between 60 and 69 scored less than 80. I want to count them. Those students between 70 and 79 scored less than 80. I'm going to count those. But any students in this bar scored 80 or 89, which is not less than 80, nor those students that scored in the 90s didn't score less than 80. To get the answer to this part, I'm just going to add up the 5, the 10, and the 15, and that's going to give me 30 students scored less than 80. For part B, a score of 70 or above is considered passing. These students that scored 70 to 79, these that scored 80 to 89, those that scored 90 to 99 would all be classified as passing. The students that scored 50 to 59 and 60 to 69 wouldn't be in the passing category. I'm not going to count them. The number of students that passed are the 15, the 20, and the 15 that scored in the passing categories, and that's going to be 50 students that passed the test. Six wants me to do 4 different computations. To do the mean, I'm going to add up the scores. So I'm going to add up the 1, the 5, the 7, the 9, the 11, the 15, the 15, and the 21. And I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8 because there's 8 scores. It doesn't say anything about rounding, so let me not round. Hopefully it comes out nice. To do this on my calculator, I'm going to add up the scores. 1 plus 5 plus 7 plus 9 plus 11 plus 15 plus 15 plus 21 in a parentheses and divide it by 8. I get 10.5. So the mean part of this is 10.5. Let me do the mode last because I'm going to destroy the data to get the mode. And let me do the median last. And let me move on and do the mode real quickly. Mode means most, and the number that occurs the most here is 15. The mid-range is the high plus the low divided by 2. So the mid-range is going to be the low of 1 plus the high of 21 divided by 2. That's going to be 22 over 2, which is 11. The only one I haven't snuck in yet is the median, and the median means the middle. To find the middle, what I'm going to do is have the data arranged from smallest to largest and start canceling. I'm going to cancel the first and the last, the second and the second from the last, the third and the third from the last. If when I cancel, I'm left with one number, or an odd number, or one number that doesn't cancel, that number will be my median. Here, if I was going to cancel the next two, I wouldn't have any numbers left, so I can't cancel Again, my median is just going to be the average of these numbers. So my median for this is going to be this 9 plus 11, which is the two middle numbers, over 2. That's going to be 20 over 2, which is going to be 10. For 7, you need to get an average of 80 on 6 exams to get a B for a course. So the total points needed for a B is going to be 80 times 6, or 480. Ellie's got 95, 70, 50, 90, and 85 on her first 5 exams, and she wants to know what she needs to get a B. What she needs to get a B is going to be how short she is of 480. So what I'm going to do is subtract from the total points needed for a B the total points that Ellie currently has, which is 95 plus 70 plus 50 plus 90 plus 85. Ellie currently has 390 points. She needs 480 for a B, so she'll need to get a 90 on the last test to get a B. So the answer to part A of number 7, she needs 90 points to get a B. In part B of number 7, we're assuming that we're going to drop Ellie's bad test of 50 and only keep her good tests. The question is now, what would she need to get a B? Well, if we're dropping a test, you need a mean average of 80 on your best 5 exams to get a B. So in this case, if we're not counting all the tests, the total points needed for a B is now going to be 80 times the 5 best tests that we're keeping, which is 400. And then I'm going to subtract Ellie's total points so far that we're keeping. I'm just going to add up the 95, the 70, the 90, and the 85, the best 4 tests that we're keeping. That gives 340 points that she has if we're only counting her good test scores and not counting the one that's being dropped. The difference between the average of 80 you need to get on your best 5 tests minus the points that you have so far gives me the 60 points that she's going to need to get a B if her lowest test is being dropped. Last problem on this part of the review gives me some data, and it wants me to find the range, which is different than the mid-range and the standard deviation. I'm going to do the range by hand. Range is different than mid-range. Range is just high minus low. And in this particular data, the high number is 14, the low number is 2. The range for this data is going to be 12. The standard deviation I did once or twice in the video by hand, and it was kind of a nuisance to do. I'm going to get the standard deviation by using my calculator, and very specifically, I'm going to get an S on my calculator. I have 1 minute before the video pauses out. Let me try to do this in 1 minute. So to get a standard deviation, I hit the Stat button, I type Edit, I go to the top of every list that has numbers in it, I hit Clear and Enter. Clear and Enter. Now in list 1, I'm going to type the numbers 2, 4, 6, 8, 10, 12, and 14. Once I have the numbers in, I hit the Stat button, I arrow over to Calc, and I hit Enter twice on one variable stats. I take the number that's the S and round to 2 decimals, which is 4.32. The answer 8 is 4.32, and my video just hiccuped. So let me go through that real slowly, and I'll just do a 2-part. I'll seam these parts together. So to do this, I go Stat, hit Enter on Edit, get up to the top of any list, hit Clear, and then Enter, and then type the numbers here, 2, 4, 6, 8, 10, 12. Hit the Stat button, arrow over to Calc, go to one variable stats, and hit Enter twice. The S number is my standard deviation, which all of a sudden now I have 3.74. Interesting. Let me check my data. because I got a different number. Edit 2, 4, I forgot the 14. Yeah, we're on 2, 4, 6, 8, 10, 12, 14, and then stat, calc, enter, enter, and I get that 4.32. It's real important that when you enter the data that you're entering it in list 1. If you don't put it in list 1, what you'd have to do is slightly different to get the standard deviation. Alright, so that's everything from part 1 of our practice test. Hopefully that was friendly. When you get to part 2, you're absolutely going to need your TI calculator.